Hey everyone, and welcome to our lesson on scientific notation. Scientific notation is simply a shorter form of a very large number or a very small number. And we're going to use this notation in many fields in the real world, including engineering and medical fields, astronomy or banking, and there are many others. Any type of field that needs to express a very large quantity or small quantity in a shortened form. So what does it look like? Scientific notation is simply going to be a number with a decimal multiplied by 10 to some power. I'm going to show you how to convert your numbers to that form. The first thing you're going to want to do is place your decimal after the first non-zero digit that you see and keep all of the digits intact. And then you're going to look to see if you have a positive number or a negative number. Okay? Talking about the exponent, we need a positive exponent if our number is bigger than or equal to 1, and we're going to need to use a negative exponent if our number is less than 1. So here are some examples. Notice that this is a very large number and is definitely bigger than 1, so our exponent is going to be positive. The first thing we have to do is we have to place our decimal after the first non-zero digit, and that is our 4. So I'm going to rewrite all of these digits, placing the decimal there. Okay? I will not need these zeros because that's going to be taken care of when we write this as multiplied by 10 to a power. Okay, our next task is to figure out what that power should be on 10. So remember, we have a positive number. That means it's going to be a positive power. We have a number bigger than 1. From where our decimal place was located in the beginning to where we are placing it, we need to figure out how many spots that moved. So let's count over. So we're moving 1, 2, 3, 4, 5, 6, 7, 8 spots from where it was located to where we're now placing it. That means our power is going to be 8. Change in location of 8 spots. Alright, let's take a look at this second one. Again, the first non-zero digit that I see is a 4, so I'm going to place my decimal after that first non-zero digit, like always. And now I'm going to see how many spots the decimal has moved from the location it started in to the location I'm placing it in. So let's count. 1, 2, 3. Remember, here is where we're putting our decimal. So 3 spots. That means 10 is going to have a power of 3. But we started with a number that's smaller than 1 this time. 0.00472. That's smaller than 1. So it should be a negative 3. Alright, third example. Look for the first non-zero digit. That is our 9. So I'm going to place my decimal immediately after that digit. And I know I'm going to have this number multiplied by 10 to a power. So what is that power? So again, let's count the decimal spots that we have moved. It started here and we moved it after the 9. So that is 2 spots. Our number was bigger than 1. So that is a positive 2. That we will use for our power there. So let's review. When you're trying to figure out where the power is going to come from or what power you're going to use, you're going to count the decimal location from old to new, and it's simply going to be the number of the amount of spaces you moved. And the new decimal should always be after that first non-zero digit that you see. Alright, we're going to shift gears and look at writing numbers from scientific notation to standard form. So what if we're given a number that is already in scientific notation, but we'd like to convert it back to its normal standard form? Well, a couple things to think about. If the exponent that you see on 10 is positive, then you're going to need to move your decimal to the right. If it's negative, we're going to move it to the left. So here's an example of this. 7.693 times 10 to the 4th. What would this look like as a standard form number? Well, we're going to write out all our digits, and we're going to move 4 spots, since that is our power and it's positive, 4 spots to the right. So from your decimal, let's count over 4 spots. 1, 2, 3, 4. Notice there's an open, empty gap there. So 1, 2, 3, 4. I'm going to fill that empty space in with a 0. We call those placeholder zeros. So my new number is 76,930. All right. Let's practice again. Let's take this scientific notation number and write it in standard form. Take a look at the exponent and we see that it's a -6. So we're going to need to move to the left 6 spots this time. So I'm going to write out all my digits. And the decimal started here after the 7, and I'm going to move it to the left 6. So 1, 2, 3, 4, 5, 6. I'm out of digits, so I'm just going to fill in with those placeholder zeros. So you can see we've got 5 in front of our digits. So here's our new standard form number. All right, what about this second one? 9.645 times 10 to the second. Take a look at your power again. Notice if it's positive or negative. If it's positive, we're going to move to the right. So count over 2 spots. And our new number will have the decimal located after that 4. So here's our new number in standard form. So let's review. Decimals are always going to move according to the number that's seen in your power. Positive numbers are going to move my decimal right, while the negative ones are going to move it left. And this concludes our lesson on scientific notation.